So, greetings. Today is the 8th of February 2019. It is a Friday, and we are going to do the same thing that we do each Friday. Talk about Gluster. We have some new folks on the bridge today. And before we go, I'd like to talk about a few things. So we've been talking about GCS version 1.0 for a couple of days now, a couple of weeks. And in the recent community meeting that happened, the plan was to call out version 1.0 with GlusterFS 6. The surprise in the package is that the cattle mode for Gluster is coming up version 2.0 GCS, so something to look forward to. With us today we have Amar, who's been here for I think all the episodes that we have done. We have Aravinda and we have Raghavendra got up, who's actually going to talk about something very interesting, and we'll circle back to it. But I'm going to kick this off with Aravinda, who's going to talk us through about something that's in tech preview in GCS, and he's very well positioned to give us an introduction to what's happening there. Aravinda, all yours.
Yeah, thanks, Sankarshan. So till now in the GCS, we had options to create the volumes using the LUM brick. So similar to that, we'll be adding the loopback based bricks for as a tech preview feature. So this loopback based bricks is like these bricks are more scalable than compared to LVM bricks. So this will be this can be configured using the additional storage class configurations. These loopback bricks can be made default, or it can be made optional. These features will be available with the GCS. Yeah.
But why are we trying the loopback, Aravinda? What do we gain from it?
Yeah, previously we tried to scale LVM based bricks for the 1000 volumes or more than that. So the creating more LVs in a single node is not scalable with the LVM. So with the loopback based bricks, so these bricks will have independent file system, so not tied together for like similar to LVM. There is nothing manages all the bricks. So these loopback bricks are more scalable and consumes less. What is it? So more performant, may not be more performant, but it will be like more scalable than the LVM bricks.
So what you are suggesting is basically that in terms of resource management in a cluster, while looking at highly dense clusters with volumes, loopback is probably one of the options that the user has while deploying to be able to get a more performant cluster, right?
Correct. So when we create more bricks in a node, so with the LVM there will be like metadata lock, and so while deleting the LV or creating LV, there needs to be lock to be held on the LVM metadata. So all those things will not be there in the loopback case. So and like the creation and deletion time is also very quick compared to the loopback, or like compared to the LVM bricks. So and other advantage we have with the loopback thing is like, since it is a file in the backend in the file system, so all the data services like snapshot, which can be done using reflink, or the backup can be done by just copying one file in the backend.
So improve serviceability as well when the user is looking at managing their clusters, managing their data, doing any migrations and all of that.
Yeah, that's correct.
Quick question for you though. So you said that the plan is to give it as an option for users. And is this option expected to be available during the install time when they write out declare how they want to install it?
Yeah, it can be made like multiple options available. One is having like providing as a configuration item in the storage class, so user can define their own storage class and use it. So otherwise in the deployment we can have it a default option, and so all the new volumes created will use this feature instead of using LVM feature. So both can be provided.
Fantastic. Great. So when we post the notes for this episode, we will try and link to the design or even the PR or the set of PRs that are on the topic. So I'm going to reach out to you so that we can have those hyperlinks in place.
Sure.
Lovely. Thank you. So there are other things that we want to talk about, but let's get to the interesting part, which is database workloads on GlusterFS have always been a bit of an iffy affair. There's been a whole lot of anxiety and angst on the mailing list. There's a lot of configuration details. There's a lot of topics that have come up. And I know that Raghavendra, Poornima, and Zavi have been working on this. And Raghavendra, walk us through as to where we are, what improvements have happened, and how do you see this coming along?
Thanks, Sankarshan. Yeah, so DB workloads, especially the Postgres, has been an issue from quite some time. So we have been hearing functional issues, as in when you start up a PG benchmark, the users ran into errors saying that the file is corrupted. So we started working on this maybe at around 4 to 6 months back. From then on, we have fixed the functional issues on the default default cluster stack. Post that, once we fixed the functional issues, then we concentrated on the performance. When we started out with the performance was not really great. The initialization of a DB with scale 8000 took around approximately 20 plus hours, I think. So, and the transaction phase basically gave us around 750 transactions per second. So I'll walk you through the functional issues and then what we did to fix up performance part.
Yeah,
so,
highlight for us the key blockers, the ones that are showstoppers, so that we can actually get a sense of the lay of the land.
Sure, Sankarshan. So the functional issues happen to be the race conditions or the bugs in the individual translators, like right behind or start prefetch. So basically, the interactions caused some stale stat being updated in the cache and the application reading that stale stat. So that resulted in the application thinking that the file got corrupted. So once we fixed that, we concentrated on the performance. With respect to the performance, the Postgres application itself can be split into two phases. Basically, it runs in the init phase where you create a database, and then you run the benchmarks on the database. So the init phase is basically write heavy and read heavy. So it writes all the data to the file, and then it reads back that data and do some computation on that. So basically, it's a workload which would benefit with the read, write, and the metadata cache actually. So the problem what we faced was basically mainly with the read after write cache kind of thing. So basically, what happens is when you write some data and then read back the same data, it's good for the performance if you can get the data being read from the cache itself. But with GlusterFS, that was not happening due to some invalidation policies we have configured with the Fuse kernel module. So in the normal course of action, we would expect the reads should be served from the kernel page cache. But we had enabled the auto-invalidation, and that basically invalidated the kernel page cache, and hence the kernel page cache couldn't serve the reads, and all the reads went through the entire stack and reached the brick and then back to the application. So this this increased the latency, and Postgres being the one of the applications which is very sensitive to latency, the init phase took 20 plus odd hours. So once we fix that auto-invalidation part, we could retain the page cache even for the read phase, and hence we reduce the time to around 8,000 seconds. So from 16,000 plus seconds to around 8,000 seconds. So that was a big improvement. There were also other improvements which factored in, but what I listed is the major one, the kernel, the effectiveness of the kernel page cache. So the other parts is basically bringing down the latency in the write path. So right behind, normally we expect the right behind to improve the write latencies there. But again, due to the fuse kernel module sending frequent fstats, the write behind was not functioning optimally actually. So we reached out to the fuse maintainer Miklos, and he was able to fix a patch to avoid the stats in the read code path. Since the reads and writes were being interleaved here, we saw the fstats in the write code path too. So once that is fixed, we can use the write behind, and we could also enable the MD cache because we fixed the functional issues. So once the GlusterFS stack is fixed for any functional issues, and we also optimize the page cache for serving the reads, we were able to get a good improvements there. So that's about the init phase. And the transaction phase, it's behaves a bit differently from the init phase actually. So the read caching, which made such a huge difference in the init phase, it doesn't have a similar effect in the transaction phase. So the transaction phase is primarily concentrated on the gets affected from the write latency. So which means that anything in the right path, like the AFR transactions or erasure coded transactions in EC module, those and all comes into picture. So with some improvements with the for the eagle locking mechanism in AFR, the write latency was reduced, and that benefited quite a bit for the transaction phase, and being able to enable write behind, that also cut down the write latency. And we also had some other optimizations like increasing the concurrency in the stack by increasing the threads, like the client IO threads or the client event threads and the server event threads. So by having the optimal value of those threads and enabling the other translator like open behind, again the open behind benefits for the stat workload, and stat being the one of the dominant operations being done. The transactions phase, we could see the benefit there too. At this point in time, we can get the transactions around 1,500 to 1,800 TPS, that is transactions per second. So that's an improvement of around 1,000 transactions per second from when we started out. So yeah, that's the high level update on that topic.
So the thing that naturally follows up from here is this is a whole lot of work, the synthesis of a multiple avenues coming together to make this workload more being better handled on Gluster, right? Are there any specific threads that the user should be looking into to be able to understand what configuration details they need to change, or is this happening right out of the box? Choose a few translators to switch on and off, and then you just get a performant Postgres on Gluster.
Yeah, so there is a little bit of tuning that needs to be done as of now. But we'll try to make it as simple to the user as possible. So I'm plan to come up with a blog on this, which will have a more detailed report, and that will have a synthesized configuration listing actually. So that should help the users.
Fantastic, cool. Looking forward to that blog, and hopefully once you get it posted, we are going to have you back here again and talk more about any specific upcoming work in the same area or any other workloads that you're focusing on. Good, thank you.
Thanks, Sankarshan.
The other few things that I want to point out before we end today is that there's been not a small number, but a fairly large number of mails on the mailing list about GlusterFS 5.3. There's specific concerns that are being observed, and the developers are picking up the issues and debugging to be able to see what exactly is happening. Those who are waiting for the Gluster 6 release, you might want to take note that there is a bunch of patches that are being on the watch list, so to speak. These are related to performance issues. Amar and others are reviewing them before merging so that we can get to a release that is better. That's all we have today. Thank you for joining in, Aravinda and Raghavendra. And we'll see how the next week rolls out. All of you have a good weekend. Thank you so much.
Thank you, Sankarshan.
Thank you, Sankarshan.